Hi friends, welcome to the aeronautical science videos. Now let us see about the aircraft performance, stability and control. In this lecture 2, let us see about the different types of drag that affects the aircraft performance, stability and control. Now let us see the different types of drag. In that first one, there is the pressure drag or the form drag. This drag is produced due to the components of the pressure forces in the direction of the relative wind and in the direction opposite to the relative wind. It depends upon the shape and size of the body. So the more aerodynamic the shape, the pressure drag can be reduced. Kindly note that the pressure drag cannot be zero, okay? Next, let us see about the skin friction drag. It is the drag caused by the friction of a fluid against the surface of an object that is moving through it. It is directly proportional to the area of the surface in contact with the fluid and increases with the square of the velocity. So the more the velocity, the skin friction drag will be more, okay? So kindly note here, the skin friction drag is increased because of the rivets which are being placed in the wing surface, and the mold and the gaps in between the control surfaces increases this skin friction drag, okay? So making this so more aerodynamic the shape and more smooth surfaces reduces the skin friction drag. Now let us see about the interference drag. Interference drag is the drag that is generated by the mixing of airflow streamlines. Kindly note, it is generated by the mixing of airflow streamlines in between the airframe components such as the wing and the fuselage, the engine payload and the wing. This drag is found to be much more in the transonic regime, that is also known as the transonic drag race. So in this picture we can see that in the joints like the wing and the fuselage joints, the engine payload and the wing joints, the horizontal stabilizer and the fuselage joints, the interference drag is more, okay? Next, let us see about the wave drag. The wave drag is most important in the supersonic flights. The wave drag is caused by the formation of shock waves around the aircraft in the supersonic flight or around some surfaces of the aircraft whilst in the transonic flight. So the wave drag will be more on the supersonic regime flight, okay? So we can see this wave drag in detail in the in the upcoming aerodynamic classes, okay? So it is the most important topic in the supersonic flight. Next, let us see about the trim drag. Whenever an aircraft is distributed by some gust or wind shear or some crosswinds, etc., in order to bring it back to the equilibrium, some controls are deployed. These controls are nothing but the trim tab which are being located at the rudder surface and the elevator surface, and some flaps. These trim tags have been located due to make the aircraft in equilibrium in the crosswinds. This deployment of controls comes with the penalty of some little increase in drag, which is known as the trim drag, okay? Next, let us see about the induced drag. The induced drag is formed due to the formation of lift. It is the lift dependent drag which is called as the trailing vortex drag. So how it is formed? By the formation of lift. Let us see it. As we all know that air below the wing is at high pressure and the air above the wing is at the low pressure. So to compensate the pressure difference, the pressure moves from the high pressure to the low pressure. So this airflow from the high pressure region from below the wing to the above wing, there is some airflow, which this airflow forms some trailing vortex. This is called the induced drag. So the induced drag formula di is equal to of rho b squared s CDI. CDI is nothing but the coefficient of induced drag. The coefficient of induced drag formula is CDI is equal to CL squared by pi AR E. The AR is nothing but the aspect ratio and E is the efficiency factor. So from this formula we can see that the induced drag can be reduced by the increase in the aspect ratio. By increasing the aspect ratio, the induced drag will be reduced. The increase in aspect ratio is nothing but the increasing the wingspan area. So the higher the aspect ratio of the wing will produce less induced drag than a wing of the low aspect ratio, because there is a less air disturbance at the tip of the longer thinner wing. So in the recent days, the induced drag has also been reduced in the aircraft by placing the winglets. So by placing these winglets, the induced drag is being minimized. Okay. Next, let us see about the ram drag. The transformation of the high kinetic energy into the static pressure raised in the passive device like diffuser is called the ram effect. This flowing of fluid particles is associated to an increment in drag termed as the ram drag. Okay. Next, let us see about the COWL drag. When the air flows around the engine nozzle, it absorbs some heat. Due to the rise in temperature of the fluid particles, the pressure increases, which gives rise to the increment in drag. This is nothing but the cooling effect. Okay, this is called the COWL drag. Next, let us see about the PARASITE drag. The PARASITE drag is that caused by the form resistance. Okay, form resistance, that is due to the shape and size of the aircraft, the skin friction drag, the interference drag. Okay, and all other elements and all other drag elements, but the elements that are not contributing to the lift, that is except the induced drag. Okay, it is the summation of all drags except the induced drag, that is called the PARASITE drag. Now let us see about the profile drag. The profile drag is the summation of the form drag or the pressure drag and the skin friction drag. The profile drag coefficient CD0 remains constant for the change in Mach number, such that the profile drag is given by profile drag dP is equal to of rho v squared s CD0. CD0 is the profile drag coefficient. Okay, so these are all about the different types of drag, friends. So these are all the drag which affects the aircraft performance in the aircraft. Okay, thank you.